Okay, 11-3, scatterplots and line of fit. So we talked about what bivariate data was before. So bivariate data just means there's two variables that are related. So now we're going to, instead of using a two-way frequency table, we're going to use scatter plots. So what is a scatter plot? It is a method to organize bivariate data on an XY plane. Okay, so we can use a scatter plot. So you should have learned about scatter plots in the past. We're going to review them and then talk about how to write the equations of a scatter plot. So there's three different types of correlation that can occur between the points. Positive correlation is when the two sets of data are related, and as one increases, so as x increases, y increases as well. So they go in the same direction. Or if x was decreasing, y would be decreasing. Okay, negative correlation as x increases, y decreases. And so you can kind of, if you draw a line through the center of the data, you can see this is going in a positive direction, has a positive slope, and here it would be going in a negative direction or a negative slope. And no correlation means there's not enough, there's no linear method to this. It's not lined up. This data is scattered. Okay. So example 1, the graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, and no correlation. And then it says describe the meaning. So if we look at this carefully, it looks like it's trending linear, going down. So this is a negative correlation. And what does it mean? Let's look at the situation. So as the years increase, so as time goes on, what's happening to the students per computer? The number of students per computer is decreasing. So what does that mean? When you have a school population, you say how many students in a school, say 500 students, and there's 20 computers. Then you take 500 divided by 20. That tells you how many computers have to be shared by each student. So what this is saying is over time, the school is getting, the population is probably staying the same, but there's getting more and more computers. So therefore, less students have to share a computer. And as our school with the 7th and 8th grade went to 1-to-1, so that would be one student per computer. That's what that means. So that's what the idea of students per computer is referring to. So that's a negative correlation. As years increase, students per computer decreases. Example 2, we've got the graph shows the number of mail order prescriptions. So that's prescriptions people get mailed to them in the mail. Determine whether the graph shows a positive, negative, or no correlation, and then describe it. So this is very clearly a linear, and it's going up. So it's a positive correlation. And so as time increases, the number of mail order prescriptions also increases. And so this is less people going to drive to the pharmacy or get their medicine at the pharmacy. Instead, they're getting it through the mail. It seems it's typically cheaper to get it that way. So that's why more people are doing it. And obviously more people are ordering things through the mail now than they used to anyway. So the line of fit is what I've been drawing here. So it's an estimated line to represent the data. It should go through the middle of the points. And there should be approximate the equal number of points on each side. So like if you look at this line, they're all on the line. But if we look at the previous one, I drew the line, and there's some above and some below. It should be approximately equal. Okay. So using a linear function to model data. Step 1, you make a scatter plot to determine if there's any relationship. Step 2, draw the line of fit. Step 3, use 2 points on the line to write the equation for the line, and then use the line of fit to make predictions. So that's what we're going to be doing on the next 2 problems. So example 3, the table shows the world population growing at a rapid rate. Identify the independent and dependent variables, make a scatter plot, and determine the relationship if it exists. So the year is the independent always, because we can't control the year. Time happens no matter what. So the year goes along the x-axis, and the population depends on what year it is. So that's the dependent. Okay, and we're going to graph these. So this is 1500 and 1600. So 1650 would be between these two, and it's at 500, which would be right between 0 and 1000. And then 1850 would be between these two, and that's at 1000. And then 1930 would be a little past 19, and that's at 2000. And then 1975 would be almost to the 2000, and that's at 4000. And then 2004, a little past the 2000, is at 6400. So there's our points. So is there a relationship? Yeah, it looks like it's going up, right? And if we draw our line of fit like that, we got a couple points above and a couple points below. Okay, so we draw the line of fit, and this is write the slope-intercept equation for the line of fit. So if we want to write the equation of this line, we need to pick 2 points. Because there's only 1 point on our line, we can pick one above and one below to use as this. When you get to do the worksheet, it's going to tell you which points to use. But for now, I'm going to pick. So I'm going to use this point here, which was the 1850, 1000. And I'm going to use the point up here, which was the 2004, 6400. So if we want to write the slope-intercept form of a line, this is going way back in time, we have to start off by writing point slope. So point slope is y minus y1 equals mx minus x1. So that's point slope. Okay? And once we get it in point slope form, then we can go to slope-intercept. So the first thing we need to do is pick one of the 2 points to be x1, y1. I'm going to use this one. So x1, y1 is that. And then we need a slope. So how do we find the slope? We do the change in y. So if we're at 1000, we went to 6400. That's up by 5400. So change in y. And then it went year-wise, went up by 154. So our slope is 5400 divided by 154, which is 35.1. So now we're going to plug in our x1, y1, and our m for slope into this equation. So y minus 1000 equals 35.1, x minus 1850. Okay, and it says to put it in slope-intercept. So slope-intercept means you solve for y. So we're going to get the y all by itself. So we're going to keep the y minus 1000. We're going to distribute here. 35.1x minus 35.1 times 1850 is 64935. And then we're going to add the 1000. And we're going to get y equals 35.1x minus 63935. And that's our slope-intercept equation. So again, we put it in point slope by picking one of the 2 points, using both points to find the slope, and then using one of the 2 points and plug into point slope. Once you're in point slope, you're going to rearrange till you get y by itself. And now we're going to use our equation to predict the population in 2020. So we're going to put y equals 35.1. We're going to replace x with the year 2020 minus 63935. And if I put that in my calculator, 35.1 times 2020 is 70,902 minus 63,935. I get y equals 6967. Remember, this is in millions. So 6,967 million people, right, is what it would predict the population being. So that's the steps we're going to use to do the next problem, and then you're going to do some problems on your own. You're going to do only one of these completely on your own today, and you'll have more practice the next day. So baseball, the table shows the average length in minutes of a professional baseball game in selected years. So year 92 is 170. The year 94 is at 174. The year 96 is at 171. The year 98 is at 168. The year 2000 is at 178. And then 2002 is at 172. And 2004 is at 167. And so we draw the scatter plot. Is there any relationship? In this one, there is no correlation. So what does that mean? The length of the baseball game did not change over time. It's scattered. There isn't a relationship between the year and the length of the game. So what does the scatter plot show? There is no relationship between the year and length of game. And because of that, we do not need to draw a line of fit or write the equation. We can't predict anything because there is no connection. So make sure when you're doing your worksheet, the beginning is just going to ask you positive or negative correlation, explain what it means. So make sure you do write whether it's positive or negative or no correlation. And if it's positive or negative, explain what it means. And then there's one problem once you're going to use the same process we used here. So go back and follow these notes carefully to do that problem. Or come to the live class and I'll help you do it.